Yeah, we are live. Hi, German.
Hello, Chair.
Hi everyone. Thanks for joining us today on a Saturday afternoon. We hope you are having a great weekend so far. And I'm Jia Sing from the Google Developer Relations team. And this is German from Flutter Singapore.
Yeah, so thank you, Chair, for helping us to organize this meetup.
No problem at all. Yeah, so before we begin today's session, let me just briefly introduce who we are and what Google Developer Space does. So we are a platform for developers and startups from around the region to learn and connect with one another. And as part of the developer relations team, we empower and connect the community to our people, programs, network, and technologies. And we've been seeing a lot of interest surrounding Flutter in our region. So we are really excited for today's session. We have awesome speakers and sessions lined up. So without further ado, I'll hand the stage over to German, the organizer of Flutter Singapore, to share more about today's session. Over to you, German.
Thank you. Again, thanks Google DevSpace again for supporting us. And today we have our fifth meetup that we started a couple of years ago, about 3 years ago. And before it was a really small community and usage of Flutter. Now we see increased interest or constantly increasing interest everywhere from different developers. And today we have 3 talks from different speakers. And I'm really happy to invite the first one, Aseem. Let me add you. Yeah. Hello, Aseem.
Hello, German, and hello, Singapore.
So what you will talk today about?
So today's talk, I would be presenting an overview about how we can create a command line interface using Dart.
So it's one more usage of Dart. Before it started only with Flutter, and today we expand this to more use cases. So
yes,
let's start.
Okay. So hello all, good afternoon, good morning, or good evening in whichever time zone you are. I would be the first speaker. My name is Aseem Wangoo, and I would be the first person to ruin your Saturday. So please bear with me. So without further ado, let's jump onto the topic, Dart and CLI, command line interface. So know me, I am currently employed at Livemore. I'm senior software engineer at Livemore, which is a personal development app. I also created this website, Flutter with Flutter. I am a writer at Flutter community, Medium Flutter community. I create small YouTube videos and blog also about Livemore. So this is basically a personal development app. In this app, you have free access to content. You can ask questions to experts for free. So you can have even live sessions with those experts. And there are some courses catered for personal development use cases specific to the users. You can avail those also. And finally, yes, it is with Flutter. So now, just let's deep dive into the topic. And before we deep dive, let me give you an introduction to Dart. Just a brief introduction. So what is Dart? It is basically an open source programming language. It was released, or I should say, the first stable release of this language was in 2011, and it is developed by Google. So let's see where to use Dart. Dart can be used in mobiles, can be used on desktops, can be used in server frameworks, and can be used now in web. On the right-hand side, you can see a small, it is a flowchart or a diagram which shows how we can use different Dart VMs in production as well as development. So on the dark blue side, it's the development toolchain given supported by Dart. So it's a different compiled version for that, which we use in our development purpose. And once we choose to go to production, we choose to go with a different runtime, which is compatible or suitable for production use cases. Now let's see one by one how is Dart used in these 4 use cases. So using Dart in mobiles. So Dart is used in mobiles using Flutter, which is a UI framework for creating cross-platform apps. Second, Dart in desktop. So Dart is used in desktop using Flutter desktop. Third, web. So we have frameworks dedicated or built in Dart called, let's say, Angular Dart or Flutter for web. And finally, we have server frameworks, and for example, Aqueduct, which is made in Dart. And this is an example of a Dart program which is running on Android, iOS, web, Mac, and Chrome. This is basically a game called as Kenken. So this is running on Chrome now. Now this is the Android. So this is the iOS, web, Mac, and finally Chrome. Now let's see what does a simple Dart program look like. So every Dart program enters using a main function, as you can see on the right hand side. So this file is called as main.dart, and let's say you want to run this program, you will simply call this dart run and the name of your file, which is main.dart in our case. The output of this main.dart or this program is hello Singapore, as we have specified in the print statement. Now as we saw what does a simple Dart program look like, let's see how we can use Dart to make a command line interface. So making CLI, how we can achieve this? Using Dart to native. So what Dart to native does, it compiles the Dart program to native machine code. So for example, if you want your Hello World or your Hello Singapore application program to run on your desktop OS, you will just use this Dart to native command to make it executable. As we say previously, the output is an executable, and yes, it is supported on Windows, Mac OS, and Linux. Let's talk about Dart to native now. And firstly, let's give an overview of Dart to native. So a long time, Dart has supported AOT compilation, but that was only exposed for iOS and Android. So on the right-hand side, as you can see, one of the previous slides had this diagram. So there are different, so Dart uses a different compiler for development and a different compiler for production use cases. So this was already available a long time, but this functionality was exposed only for iOS and Android. Hence, Flutter, when it came out initially, was focused heavily on iOS and Android. But now, with the use of Dart to native, Dart framework has extended its compilation support for Mac OS, Windows, and Linux. So what is Dart to native? Before we see what's Dart to native, so this is an announcement, this is basically a command line interface, which was created by Dart team to announce this feature Dart to native. So the command line interface is run by /announce, and this is entirely programmed in Dart. So what is Dart to native? It's an extension of Dart compiler. Second, what it does, it compiles your Dart programs, Hello World, or starting from a simple Hello World to a very complex, to self-contained executables. And thirdly, it is compatible with Dart FFI, which is called as Foreign Function Interface. Let's see a bit about what is this third point, compatible with Dart FFI means. So basically, all your native functionality or all your operating systems were created are using the libraries which are written in C. So all the core system libraries of any operating system are in C. And let's say your application, let's say in our case, that has to access these native functionality from operating systems, which is C library. So with using that to native, we can access system libraries since the feature of FFI is supported by that to native. So using FFI, you can talk with C libraries, you can send the response or you can get the response from these system libraries, and you can use the output or whatever depends on your use case using that to native in your command line interfaces. So now let's see how we can create an executable using that to native. For creating executable, first we need to specify a source file, which is main.dat in our case, displayed on the top picture. Secondly, once we have finalized our program, we want to create an executable now. What we do is we use that to native. The command used for creating a source program to an executable is this, that to native space source file space -o, which stands for output, and space executable name. So our source file is main.dat, and the executable name, which we say is hello in our case. So in the final step, the executable which is generated is named as hello. So this was the process for creating our simple hello world or hello Singapore to an executable running. So now if we talk about the comparison between .vm and .native, so there is an open issue addressed by people doing this feature or people using this feature that .native is somewhat slower than .vm. So link of this issue is mentioned in the slide description. So .vm, what it does, it uses JIT or just-in-time compiler, which is good for development purposes, but it has slow startups, but guarantees for good performance, suited for development purposes. Whereas on the other hand, .native, it can be used to create, it uses AOT compilation, which is recommended for production use cases. It has fast startup, but has consistent runtime performance. So this issue is currently active, and people are actively trying to make this comparison even less seeable. So let's see now how we can create, using that to native, how we can create our own CLI, which is called crypto in our case. So let's give an introduction about crypto. So this is a command line interface made with that to native. What it does, it fetches Bitcoin price from CoinDesk API. And what's the output of this? We show the price of Bitcoin in USD, Euro, and GBP. This is an overview or how this command line interface looks like. So we have exposed a command called as BDC. And on the right-hand side picture, you can see our CLI shows us, hey, these are the available commands. Hey, this is the info for this CLI, and some options like help or usage. Now, let's say if the user types in the command correctly, command which is BTC in our case. So the user types in BTC correct command, we process the command, and we fetch the API price from the API and show it to the user. And as we said, the BTC price is showed in USD, Euro, and Pound. Let's say our dear user doesn't type in the correct command. So we need to cater for those use cases also. So we catch these cases and we give a description that, hey, we couldn't find a command called as XYZ or whatever the user would have typed. And we show the user errors specified that, and also we say that, hey, by the way, the available commands are BDC. So how was this crypto CLI prepared, or what's the recipe of this crypto CLI? So this uses two packages. First is HTTP package. This package is used for calling API for getting Bitcoin prices. And second is the args package. This was used to define our command BTC. And these two packages are available on pub.dev. So let's see different steps to create our crypto. So currently there are 4 steps. Let's see one by one. So first step is we create our command. We have an abstract class called as base CLI command. Basically, it just includes that, hey, you need to specify a name of the command, you need to specify description, and we have written a method which would need to be overridden if someone extends this abstract class. So our crypto command is a class which extends this abstract class. So by right, we need to define our own command, which we say BTC in our case. We give it a description that, let's say, hey, it shows the price of Bitcoin, and we override the run method. And in this run method, here is the crypto API call. Basically, this in fetch data function calls in the HTTP, sends the HTTP request to the Coindesk API and gets back the data. Second step. So we need to define our command now. So we define command using command runner. So this comes from a package args, and we specify this requires 2 parameters. So first is the executable name, and second is the description. So in the description, we say that, hey, just whenever the CLI runs, just show the user that this is the info for this command. And now the third step would be to register this command so that our CLI would not recognize this. So third step, register and run. So we register our crypto command using runner, which comes from the command runner package. And now using this, we register that, hey, our CLI will respond to this command, which is the crypto command, and crypto command includes the command BTC. Finally, we run this, we register and run this command. And let's say for use cases where the user doesn't type the correct command, we need to cater for those also. So for that, we first print out the error, and finally we exit our CLI using exit code. So this exit code comes from that IO package. And exit code 1 means terminate the application. Finally, we generate our executable. So this is done again using .NATIVE, where, as we had shown in previous slides, we have to specify our source file, we have to specify our executable name. So in our case, our source file is crypto.dat, and the executable name, what we say, is crypto. So when we run this command, .NATIVE crypto.dat -o crypto, we get an executable crypto. So let's see the demo in action. So this is our application, crypto. Let me make it bigger. So this, when I run the CLI, it shows me what are the available commands. I know now, hey, okay, BTC is the command which is available in the CLI, and some info about this CLI, which says, hey, know the price of BTC. Now, as we try to be a good citizen and we do what this command line interface has exposed, we type in the correct command, which is BTC. And it gives us the price of Bitcoin in USD, Euro, Pound, along with the timestamp when it was called. Now, let's say we try to not to be a good citizen and we just type anything. So it says, hey, we couldn't find a command called XYZ. And now also let's try to add a new command. So for that, I have this hello command. We will add this command. So what's this hello command look like? So this contains a description that say hello, and what is the name of this command, which is hello. So now let's recompile our CLI so that this hello command is registered. We use .native crypto.dat, which is our entry file, and the output we specify as crypto. So this generates our CLI with the new command. Okay, so now our CLI generated is crypto. Now let's simply try running this CLI, and it should show us the available commands as hello and BTC. And yes, it does here. So we can see the new command added is hello, and the description is say hello. So now let's try to enter this command. So it shows us hello folks, and we have already the run method in this hello command to print us hello folks. And just to make sure that we didn't break the previous command, we will again type BTC, and it still works. It gives us the price. And yeah, so moving back to our slides. So now, what is the execution time for crypto? So that can be achieved using time. So time is a command. So we say time and our CLI, which is crypto in our case. So after running this, we see that this crypto CLI exits in about 79 milliseconds. And for, let's say in the demo, we try to see how much time it takes. So yeah, it takes still 77 seconds, milliseconds. Let's switch back to the slides again. And so the other options available in .native are -h, which is used to display help for all options, and -k, which we can use to specify our output type, whether it is AOT or EXE. By the way, it defaults to EXE, which if we haven't specified -k. And finally, -o or -o, which is used to specify the output. And if we don't specify the path, it assumes that you want your CLI to be created in the directory in which it's running. So in our case, crypto was generated in the same folder, or in the same hierarchy where this entry file was. And yes, there are some other options also available in .native. So what lies ahead? We can use that in Cloud Run. You can containerize applications using that and deploy on Google Cloud Run. You can also write cloud functions using that now. So this is available using Functions Framework. So this is a package also available in pub.dev. On the right-hand side, you can see how we can use that to create a cloud function. So using this Functions Framework is imported, and the person types in that, hey, okay, if a request is sent, you would respond, hello world. And the output of this function is hello world once if you try to curl the HTTP generated after this cloud function is deployed somewhere, or if it's running locally. So what are the limitations of .native? Yes, there are some. So first is no cross-compilation support. What this means is you need to compile separately if you want your CLI to be created on Windows or Mac OS or Linux. This is one of the limitations. Second one is there is no signing support available for the CLI executables, which are generated using .native. So basically, the executables created using .native are currently not compatible with standard signing tools like as CodeSign or Sign tools. And thirdly, currently there is no support for .developer. What this means is we cannot debug our CLI application using debugger or inspector. These things which are already available in the Flutter framework for iOS and Android. And yes, currently there is no support for DAT2 mirrors also in DAT2 native, which is primarily used for reflection. The source code for this application is here. The crypto CLI itself is here in this link. And there is a video for DAT and CLI, which is created by me. It's hosted here. My website is here. My Flutter website is here. And yeah, that's all, folks. And yes, the floor is open for questions now.
Yeah, thanks, Aseem. I think we have a few questions. Let's start with the first one from Artem. Are there any pre-built libraries for native desktop integrations, or they need to be created manually?
Sorry, are there pre-built libraries for native desktop applications? So currently, there are some libraries written in C. Those can be written or can be used using FFI, because currently DAT2 native supports this FFI. So at the moment, I would say depends on your use case. For like notification control, yes, you need to write a C bridge for now, but assume that since that is growing very popular, so maybe one day you get up and see your library already made by someone else. But for now, yes, you have to write using C bridge.
Okay, thank you. And the next question. Does the executable file can be run in multiple OSs? Do you need to recompile the code for specific platform?
So currently, this is a limitation of DAT2 native. If you want to run your executable on different OS, you need to compile it on different OS. So yeah, that's it. That's the status for now.
Okay, and I think we have one more question from Artem. Web function runs on web server, requires reverse proxy, or should be bound with module to external container?
Okay, now I see the question. So I haven't tried this web functions, so I should not misguide you. So I haven't deep dived into it, so I cannot say I know this answer. Sorry.
Hi, no problem. I think that's all with questions, at least what I see right now. Thank you. And if you would have any questions, please find link from in our Meetup group for Telegram channel, and I think you can ping Aseem there with any of your questions. Thank you. Yeah, and now let me introduce our second speaker. It's Alex. Hello, Alex.
Hey, everyone.
So Alex, actually, we have been working with Alex for like past few years, maybe 3 years, and he also works at Grab, and he's responsible for our Flutter integrations. And today, what are you going to talk us about?
Yeah, hi, German. Hi, everyone. Thanks for having me today. So today we're going to talk about how Flutter was integrated into Grab, like some aspects of it, into Grab mobile applications. And we're going to talk about specifically about problems and challenges with app-to-app at scale. So we have a lot of content here, so let's get started.
Okay, good luck.
Thanks. So yeah, thanks. Hi again. As German said, I'm working in Grab and currently focusing on developer experience for Flutter engineers and integration of Flutter into different parts of the application and integration of Flutter into our all of our mobile apps in general. So what we're going to talk about today. So first of all, we're going to uncover what is add-to-app and how is it different from the full Flutter application. Second is we're going to talk about how Flutter adoption by Grab mobile applications, and what do we actually mean when we say scale. So third, we're going to talk about add-to-app challenges and solutions that we have faced and what we have discovered, like how we can solve them. And the last but not least, we're going to talk about the future improvements that we haven't done yet, but we see these challenges and we want to work on them in the future. So first of all, what is add-to-app versus full Flutter application? So in ideal scenario, you start your new application, and because Flutter is such an amazing framework for mobile apps, and it has a lot of advantages, you start writing your Flutter application, and all your screens are in Flutter. So that's the ideal scenario, and you don't have to worry about add-to-app challenges. So that's what you want to have when you start mobile app. And basically, it's you follow the guide on Flutter Developer Portal. You run your CLI command, Flutter create my app, and it's done, right? So you proceed with your Flutter developer journey. So how is it different from add-to-app? When you start Flutter development, so when you start writing your app from scratch, you can start with Flutter. But if you have existing mobile application, maybe a lot of legacy code, and you already have some code base, and probably it's like different for iOS and Android, and maybe you want to start using Flutter to leverage all those great tools and hot reload, hot restart. You have fast developers cycle, and you want to add new screens developed in Flutter. So that's the situation with add-to-app. And usually how it's configured, you create your new Flutter module, a slightly different command. You say, hey, create my Flutter source code with a template module, and you go ahead and integrate this module into the host application. So let's talk about how did we integrate Flutter into our mobile applications, and how did it evolve? So our first usage of Flutter at Grab was our merchant application. It was it's full Flutter application. There are no problems with add-to-app that we're going to talk about later, and we were able to leverage Flutter SDK and Flutter tooling in order to provide great experience for our merchants. And next, about a year ago, we started integrating Flutter into our Grab Super App or PAX app. And there are already a few screens that are developed in Flutter, some of them in the deliveries flow, some of it in the food flow, etc. And it's added as add-to-app. We also have our driver application, and it's also started using Flutter just maybe months ago. And there's already one screen integrated into our driver application. And again, it's also added as add-to-app. And talking about scale, like we have hundreds of engineers working on, like, let's say just the super app, and we have engineers working on the driver application. So we have large developer community, and we have a huge existing code base. If we talk about the native part, right? Our native application for both iOS and Android It has more than 2 million lines of code. I think much more than that. Don't know exact number as of today. It creates like a lot of challenges, and it was actually one of the reasons we started using Flutter, because building such a huge code base without any optimizations actually is quite challenging and time consuming, especially on your local machine. With this context, let's talk about the add-to-app challenges and solutions that we have faced and that we have found. As I've said, we have hundreds of mobile engineers, and when you integrate Flutter to your app, then it means that all engineers actually have to install the Flutter SDK on their local machines, and it might be very disruptive for engineers, and it's not the experience that we wanted to have. And especially like if you have hundreds of engineers working on a native application, and maybe like 10 of them needs to work with Flutter source code, doesn't make sense for all of them to install Flutter SDK. So we found some solutions for that. So solution is pre-built binaries. So what do I mean by that? When you build your Flutter application, it produces modules that you need to integrate into the host application. And it's true for both add-to-app and for full Flutter app as well. So the output is like frameworks for or modules for iOS and Android. And so what we do for our mobile engineers that don't work with Flutter, we take these binaries and we upload them to the binary storage. And for each of the builds, we assign the build number, in this case, like 1, 2, 3, 4, 5. When engineer who doesn't have Flutter SDK on their local, they just pull these binaries from the cloud storage or from the binary storage. And for them, it's transparent. They don't even know that, okay, there's this part of code was written in Flutter, or this framework was written in Flutter. For them, it's just another binary framework that is added as dependency for my native application. So what are these binaries? Basically, they're two pieces, right? One is the Flutter engine, which contains the Flutter VM and Dart VM and some other tools that are needed for the runtime. And the other part is your source code. Basically, your application that you've written, and it's precompiled and also added as a second module to your native application. And again, this is true for both add-to-app and full Flutter app. But for native engineers, we do this optimization, so they just download it as precompiled binaries. So now our native engineers are happy, and they didn't have any disruptions. So what about our Flutter engineers? So now we say, okay, we pre-built binaries, we upload them, and for native app, we download them from the binary storage. Flutter engineers, they actually want to work with the source code, and they want to be able to build the host app with the Flutter source code. So how do we do that? Basically, let's talk about the structure of our repository and the structure of the application. So you have your Flutter source code, which is located in some folder. Along with the Flutter source code, you have folders for iOS and Android. And in our case, we are adding them as submodules. So these are existing mobile applications that we have, let's say our Grab Pack Super app. And they're added as a submodules on the same level with the Flutter source code. And Flutter source code lives in a separate repository. So basically, when we built our Android or iOS app, we can detect, oh, there is an existing folder in the same level with my Flutter source code. So I'm going to, instead of taking binaries, I will actually go ahead and use the local source code of Flutter and build my Flutter module with Flutter SDK. yeah, so this is basically what's happening. We for Android we're using Gradle to take the dependencies, and for iOS we're using pod file. So in the pod file we have the logic to check for that there is this folder, and we'll take Flutter source code from there and build the Flutter app from the source code. Same for Android. Yeah, so now we have the setup. When we just pull our Android application separately without the Flutter source code, then we'll just take the Flutter modules from binaries. So this actually creates another problem because for every version you need to upload the new binary to the binary storage, and then you need to change the version inside the host application for both iOS and Android. So updating Flutter module version is actually kind of a slow process. So let's go through how it looks like. You have your Flutter repository and you have a master branch. So you want to create a new feature. You create a branch for this feature, and after you tested it, you finished the feature, you merge it back to the master branch. So now you have, and when you merge it to the master branch, we will build new binaries that you can later add to your host application. So, and for each binary, we have a build number, let's say 1, 2, 3, 4, 5, 6. So what happens next? You need to integrate it back to both iOS and Android repositories, host applications. So same happens, right? You create a new branch, you update the version number, you merge it back to the master in Android, and then same for iOS. So this process is quite slow. It might take you around 10 minutes to manually create those merge requests, send them, approve them, etc. So the question we were asked, like, can we do better? Because again, this is quite slow. And the solution was pretty simple. We wanted to automate as much as we can. Let's look at these 3 steps, right? So you need to run CI to create binaries. You need to update the version in iOS. You need to update the version in Android. So all these pieces can be automated. The only thing you need to start this process on CI. So now how your flow looks like. You go, you create your Flutter feature branch as you did. You merge it back to master branch. And so next is actually automated. So we will create a new branch in iOS and Android. We'll update the binary version that is set in the host app, and we will create a merge request format. The only thing you need to do later is to get this merge request approved. So you still need to go through the code review process, but it's just a single line of change that you need to do. And it can save you like about 10 minutes of time. So if you think about it, it's a common practice when you build the framework that you share as like third-party framework, then you ship it, and you have versions maybe, I don't know, once a month. But if you working on the features, you probably need to do it maybe a few times a day. So it can save you like half an hour a day if you do it 3 times. So this was a major improvement in our developer experience. So this was about creating a merge request and pushing it back to the host application. So next problem that we faced was you need to create a QA build for testing. So let's go again through the process and how it looks like. So similar thing happens, right? You create a branch in the Flutter repository, and you get the build number for your new binaries. So we create new binaries running CI. Then you need to, again, create 2 branches in iOS and Android. You need to change the build number there. Then you need to build new QA, new app for testing and share it with your QA engineer. And again, it may take you like up to 10 minutes by doing all this manually. So, so this is the overview of the process again. Again, the question is, can we do better? So we thought about it and we thought, okay, we can automate it as well, at least some parts of the process. So now what happens? You have your master branch, you create your feature, you get the build number. So next, what happens is now we need to apply this change, change the build number for the Flutter modules inside host applications for iOS and Android. So instead of creating a new branch and pushing it back to repository, on our CI, we actually will apply this version number update. And without pushing it to the back to repository, we'll just run our CI command and we'll create new QA build for testing, and we'll upload it so your QA engineer can go ahead and verify that feature is working fine and it can be merged. So, and it actually helps us to reduce some. You don't need to push it back, this version update, push it back to repository when you just want to test. Maybe you want to create several versions of it. It will create extra history in your Git repository. So it's not really necessary. And it also helps us to reduce the history on the host application Git repository. Yeah, and again, this process is automated. The only thing you need to do is click a button in our CI, and this will run and will create a QA build. Yeah, so this is again the overview of how it looks like now. So next problem that we faced was because given that our especially the Grab Super app has a large legacy code of like more than 2 million lines of code, and adding new features going increasingly constantly, and we have to build the application from source code from scratch. You need at least, depending on your machine, it can take you like 20 minutes, maybe more. Yeah, so this is one of the common problems that you have, right? So you have a large application, you need to build it, so then you can embed your Flutter screens into it. And again, depending on your machine, it might take like a really long time. So the question is, again, can we do better? What we can do in order to improve developer experience? So I don't need to build entire host application, just write my Flutter, run my Flutter code. And the solution is actually pretty simple. You don't need to build entire host application from scratch. You can download it from CI. So in our CI, we have a history for each commit and master. We generate the build to verify that you can actually build the source code. Everything is fine. We also run tests, etc. But one of the artifacts of running our tests and builds is that we can take the build generated by this existing automation, download it in our local, and install it on our device. So you can install it on your iOS simulator or iOS device, or you can install it on your Android device, and then you can run this application with existing. Some of the binaries will be embedded into it, and the only thing you need to be aware about that when you create the local changes in your Flutter source code, when you attach debugger and run the host application, you need to do the hot restart in order to make sure that you have all your recent changes in Flutter source code already there in the runtime. And so that's first approach of how to solve the problem of when I don't want to build entire host application. So second approach, you don't run the host. So this is what happens, right? You run your host application, and you start the Flutter Flutter app. And your host application provides some dependencies to your Flutter application. So maybe you added some plugins with the native integrations. Maybe you provided something else. Maybe you provided some launching options for your Flutter counterpart. So in this situation, you just run the host app, start a screen that contains Flutter source code, and you can actually attach your debugger to the existing running application. So second approach is we forget about the host application whatsoever, and we just run our Flutter source code without the existing native app. In this case, you want to provide some of the dependencies that host application gives to you, like maybe some native integrations, but you need to mock them, right? So you run your app and you create a separate entry point. So you create a separate main file that you will run, and inside that alternative entry point, you provide some maybe fake dependencies, maybe you provide some predefined results for the APIs that you expect to be in the runtime from the host app. And to some extent, it may help you, especially when you just start writing a feature, so you don't depend on too many dependencies from the host app. And in this situation, you actually can reduce your development time pretty significantly. So we talked about a lot of challenges from developer standpoint, and another part, there is a customer experience, right? So we also want to delight not only our engineers, both on Flutter side and native side, we also want to delight our existing users, and so they have the best user experience possible. So when you launch Flutter screen, it may have a visible delay. So why is it happening? So when you start Flutter app, it starts the Flutter engine, and Flutter engine actually provides some functionality that is needed to run the Flutter source code. It starts .vm, it loads some Flutter shared libraries. It loads fonts, it loads your images, and runs the Dart SLA. And this actually can take maybe around 300 milliseconds, depending on the device. So it may vary, but and in this situation, your user might see some blank screen or white screen, depending on your setup. And it might be really visible, so it's not the best user experience that you might have. So here, the solution is you want to reuse the engine between Flutter screens. And this actually, if you start Flutter screen and then you go back to native, then you start another Flutter screen, then you go back to native. So every time you need to start engine, you will have this problem. So, and it might not be really an issue for existing, for full Flutter application, because you will start your Flutter engine during the app launch. And for the user, it's just, a part of the app start process, which is a pretty common thing, right? It's not so big problem when you have just a full Flutter app. So the solution is you need to reuse engine between launches. So when you can start engine at the point before you even start the Flutter screen. So maybe you go through your app launch process, and then at the point when you have time when user is not doing anything or just landed on the initial page, I might have some time to now start Flutter engine. Alternatively, you can start Flutter engine lazily when you're just starting the first Flutter screen, and then for all subsequent launches of Flutter screens, you can reuse the same engine. So now, instead of having like 300 milliseconds delay when you start Flutter screen. It will be just 10 milliseconds just to start the next screen before the first frame is rendered. Last but not the least, the documentation. Since we have a lot of different customizations to the Flutter development process, we also want to let our engineers know about them so they are not caught by surprise. So we have existing set of documentation that will walk you through this process, and maybe something that you need to know about, and some improvements that you can use in order to make your process of creating the Flutter app much better and much more pleasant. So that's what about our existing solution, like problems and solutions that we had. Next thing, we still haven't solved some of the other issues that we face. So, for example, having multiple Flutter screens at the same time. So you might have this complex scenario when you have a native screen, then you launch Flutter screen, then you go again to native, then you want to open another Flutter screen. And to do that, you need to create multiple Flutter engines. And this might be really heavy on your device, especially for some old devices, low-end devices. The experience for user might not be it might not be great. It might take just too much resources if you run multiple Flutter engines. So what you want to do is you want to reuse the same engine inside multiple Flutter screens, but it's not really supported. So we need to have a solution to solve that. There are existing frameworks that allow reusing the same engine and run multiple screens at the same time. For example, Flutter Boost by Alibaba. So we're looking into how we can solve a problem in our Grab applications. Another problem that we have is like not a huge problem, but we have existing guidelines. How should you write code? How you should integrate new screens into existing applications, and this might be it might involve like writing some boilerplate code, and for that we want to create like a set of templates so you can just generate the structure for your new screens, for your new feature, and create new experiences much faster. And another part is end-to-end testing. So you can have component testing in Flutter without the host application. But if you want to go to run UI tests that starts the native part, go through a few screens, open the Flutter part, we haven't solved this problem yet. So there is no existing like straightforward solution for that. So we're also looking into how to solve end testing problem for us. So that's it from me. There was a lot of content, guys, I know. But if you have any questions, please share.
Yeah, thanks, Alex. I would be voice of these questions. We have quite a few. So the first one from George. What challenges your team faced when trying to communicate between native parts and Flutter parts? So basically bridges.
Right. So this is like a good question. We have a large set of existing tools and frameworks for engineers to use, let's say, and so we have multiple mobile teams, and these teams can share functionality. Let's say you're in transport and you want to pick up the POI, right? And picking up POI is reused by multiple features, like inside Grab Express or inside transport, inside food. This is a pretty common functionality, so it's shared across. And same with payments, same with what else? Like there are some tools that doesn't have UI, right? Like analytics or logging, etc. And you need to expose these functionalities, existing functionalities, to the Flutter part. So we create bridges for them, and we try to reuse these bridges as much as we can across different applications. So we create a bridge, and we also try to make it in a way that we can reuse it in Grab Super App, in that driver application, in merchant application, etc. So yeah, we have pretty fine structure how to do it. Yeah. So the short answer, we are using bridges as much as we can where it's possible.
And just to add, we ask don't do it by themselves. So because it's, I think, one of the biggest pain point. So let's move on. The question from Artyom about Flutter engine, how heavy runtime memory, and probably impact on application size.
So as I said, there is a toll when you start Flutter engine, like around 300 milliseconds. In terms of the memory footprint, I think it's around, I don't have like exact number right now in my mind. I think it's around 15 megabytes for a single instance of Flutter engine. So if you create multiple instances of them, it will consume a lot of memory.
What about application upsize?
Application upsize. I think the empty Flutter app for Android takes 4 megabytes and 10 megabytes for iOS, if I'm not mistaken.
Okay, probably we have another guy from our team can answer in comments who was working on optimization for application size. Let's move on then. Question from Kazimir. What are Grab's engineers' thoughts on Flutter? What plans does Flutter have in integrating Flutter in future versions of Grab App or Grab Apps?
So we collect the developer happiness as NPS regularly. So we are looking into how engineers perceive the Flutter development flow, and so it depends on the time when you launch the investigation. But so the traction of integrating Flutter into the Grab app was pretty well accepted. So there are a lot of requests from multiple teams that, hey guys, we want to use Flutter. Like, can we use it for our use case? So a lot of engineers are pretty happy to start Flutter development. Integrating Flutter into future versions of Grab app. So again, it's already integrated. We gradually add new features. Some more and more teams start running new screens in Flutter.
Mm-hmm. And just to add a little bit, to connect with previous question, I think one of their biggest problem or negative feedback, it's whenever developers try to work with native. So with these bridges, otherwise feedback is positive. And from Blue Mars question, did you encounter any performance issues after adopting Flutter in some screens, and how was it resolved?
So I guess this, my my slide about how to improve the launch of the Flutter screen, reusing engine actually solves most of the performance problems that you might have, and limiting the amount of Flutter engines you have at the time. So we just have one, so we haven't encountered any performance issues.
Okay, thank you. And one more question. Do you think that Flutter will be keen in mobile development?
Well, this is a really, really broad question. I think it's you can look at the trends and how Flutter was adopted by the community. I think in the last few years, it's the fastest growing framework for mobile development, and more and more applications are created with Flutter. So definitely there is a bright future ahead of us. In terms of the king of mobile development, again, this is arguable, and different people can have different opinions. I think Flutter has a really interesting tools that developers can use, and it improves developer productivity quite significantly. So the future for Flutter is bright. In terms of the king, we'll see.
And I believe we have one more question. Let's take it as the last one. So, yeah, it's finally appeared here. How often platform or screen-specific hacks are required?
So I can't recall. So we had an issue with had some issues with Android when you launch Flutter activity, then you go to some another activity, then you go back. So there was an issue when you go back, you have a blank screen, and this problem we actually communicated with Google engineers in the GitHub, and they were able to respond pretty fast, and we found a solution for that. It's not happening often. I wouldn't say that it was a major problem for us. So maybe like a few times we had some specific problem related to the OS that app is running on. But it wasn't blocker for any of our features. So nothing that we couldn't have resolved.
Thank you, Alex, for your presentation. Guys, if you have any questions, again, please drop it in Telegram channel. And then let's move on to our next speaker. Sorry?
So sorry for taking too much time. Thanks, guys.
No worries. Yeah. Hello, Harris.
Hi, German.
Let's welcome Harris. I believe he is one of our most popular speakers almost every meetup. So I'm happy to see you again. And yeah, then let's start with your awesome talk.
All right, thank you, German. So, I'm going to talk about the new Material Buttons 2.0. Okay, it has some animation, guys. Cool. All right. So there is actually Material Buttons 2.0, and these are the new Material Buttons that you might have used in your Flutter app if you have upgraded your Flutter, what do you call that, version in your dev channel. So let me introduce myself. My name is Haris. I'm a Google developer expert for Flutter, and I'm a founder for Learn Flutter Code. So I create easy to understand Flutter content for developers, something like this. And I guess if you guys know me, back in 2019, I used to be a Flutter developer in this startup, which is currently called Blood. They're a feminine tech company. And interesting note, the first speaker, Aseem, used to be my worker. So he used to be my colleague. Yes. So we actually work on this app, and it's a period tracking app, and it currently has 100,000 downloads. And yeah, it's built in Flutter from its inception. So getting back to introduction to Material Buttons 2.0, these are the different questions that you might want to ask. So what is material? Is there new material buttons? What are the new material buttons? How do I use them? Flutter theming and benefits. And lastly, will the old buttons be deprecated? So these are very valid questions. So let me answer step by step, right? So the first question, what is material? So material is basically the matter from which a thing can be made by some random philosopher. No, so if you were to Google, that's literally what's the material definition. But in actual fact, you might be thinking, what are material buttons, right? Because some of you might not be using material design or material. So material buttons come from material design. And this material design is actually a design system that's created by Google to help teams build high quality digital experience for Android, iOS, Flutter, and the web. So basically Google's version of Bootstrap, right? And if you done a lot of like Flutter apps, right? When you import the library Flutter material dot, that is actually the material design library that you use. So why the need of the material design? As developers, we want to care more about the code rather than the design itself, right? So we want what material design gives is a consistent design and user experience in the app. So you don't have to create things from scratch. You don't have to create buttons. You don't have to create the app bar from scratch. So it will actually help you save some time. Then the next question is that you might be asking, what are the new, is there new material buttons? Yes. So the new material buttons is in the master channel and also the dev channel. Sorry, I've never updated, but yes. So if you are in the dev channel, you'll be able to see the new Flutter material buttons. If I'm not wrong, it should be in the stable channel as well. So what are the new material buttons? So this is like a visual way for you to see what's the old and new. The old buttons, it's pretty dull and boring. So if you were to create any button, the old way, it is according to the color gray. But if you were to create a new material button, you could see that it actually takes in the color from a theme. So if you were to put the theme of the Flutter app as purple, you could see that all of the new material buttons actually follows the color of the app, which is purple or indigo. I'm not sure. Okay, so then why the update, you might ask? So there is a couple of times where people want to use the theme to actually help, you know, color the buttons or style the buttons. But there are certain issues that actually has been what do you call that, pop up when you were to try to do that. For example, the theme dot text theme is ignored by the raised button and flat button, because I guess nobody likes to, you know, put in the color styles for every single buttons, right? Even though you can like create the global variable and whatnot, but it doesn't feel right. All right. So then the objective of the update is actually to make the individual material button theme easier, right? So because when we were to do the old way, if you were to just create on the button theming, doesn't really actually help. And then like simple changes like text, changing the text color and the theme should be easy, but it's not, because yeah, there is certain specifications that weren't added inside. And lastly, like for example, simple changes in the text color when Harvard should be possible. So all of this thing is to make it easier for you guys to actually implement in the theming of your Flutter buttons. So then how do I use the new buttons? Like Nike say, just use it. So I am actually going to actually show you how to use the new buttons. So I'm going to give you a little bit of like code, and then after that a demo on how you can use the different the new material button. So the old material button is called flat button, but the new one is called text button. Then to create them, it is as simple as just typing it out, and these are the old and new ones. If you were to want to change the color for the buttons, right, for this text or flat button, for the old one, it looks something like this. You just add in a blue color inside the parameter color. But for the new one, it's a little bit different. So you could see that there is this new thing called the button style. So the button style, you could think of as like the text style for your text widget. So the button style requires a button style object. And then this is where you're able to actually color the buttons. So inside the button style, you have a couple of, sorry, a couple of parameter, and then you have to pass in this thing called material state property. So what's that? And then you have to use this .all method to pass in this colors .blue just to color the text button. So I'm going to explain what are the different, things that is inside the new material buttons or the button style. So a button style is a simple container for your different configurations that you want to do for your buttons. And this button style is the most common thing that you'll find in a button for all of your different buttons. Yeah. So then I think a little bit more on what is material state property is that it is an interface that helps you resolve the value on your widget's interactive state. So this includes the hovered, focused, and pressed. So I guess these are like the common interactions you do on a button. If you have any other interactions with your buttons, please leave down in the comment section. So I would say a little bit an easier way to explain is basically giving you a conditional statement that returns you the value that you need. So for example, the material state property color is when you want to hover over a button, it has a different color. If it's focused, it is a different color. And then if it's pressed, it's another different color. So you can do it for your mouse cursor or even your border. So I'm going to have a little demo on how you can actually use this material state property and actually like see what is the difference between the old buttons and the new buttons. So let me go to this demo over here. So I have with me here this text button demo. And then it is a simple demo that I've created. So I have a demo scaffold. Basically, it's just laying out the different the different buttons. So I have the flat button, which is the old one, and the text button, which is the new one. So you can see the difference is that inside my main dot, right, my primary swatch or my primary color is purple. So if you were to create a simple flat button, it doesn't really like vibe, towards the color of the theme. But if you were to use the new text button, then it actually takes in the color of the theme as well. So if I were to zoom in for you guys, and I guess a little bit of a difference is that if I were to click on the flat button, right, the ripple is according to how deep your press is. So if you hold a long press, the ripple will do something like this. If you do a quick tap, it has that animation. But for the text button, a little bit different is that it actually like kind of slows down and it looks pretty nice or pretty cool, I would say. Right, so let's go back to the text button demo scaffold. And I'm going to show you on how the different way for you to actually color the new text button using the material state property. So for the flat button, you could see also at the same time, there is this flat button deprecation message over here. So if you have a Flutter project, I would recommend you to actually change it to the new one. So it's good that you are in this meetup to learn more on how you can migrate it. Okay, so I want to change a couple of things. So the first one is the colors.blue, right? So for example, I want to color my flat button to blue. So it's pretty simple for the flat button, but for the text button, you could see that I have to put in the button style. And then inside this button style, I have to use the foreground color. So foreground basically is the front part of the text button. So you could say that it is the front part, it should be the child widget of the text button. So if I were to save this, no, I'm not saving this project. Okay. So you could see that for the buttons, for the flat button, it actually changes the background to blue while the foreground is changed into blue. So another thing that you might be asking is what is this .all method? So like I said, the material state property is like a conditional. So the all is basically saying every single interaction, all of them should be in blue color in a way. But this is the foreground color, which is not exactly the different interactions that we need. So what we're going to do is we're going to change the different interactions, like for example, focus, hover color, and splash color to different colors. So for the flat button, you have these different colors, while the button style over here has this thing called the overlay color. So the overlay color is basically when it is, let me zoom in for you guys, focus, hovered, or press. So this is the property that you want to override if you want to control how it looks like. So inside this overlay color, so you use the material state property, but the resolve with is a method that actually helps you to give this different set of material state. So the different material state that you can find is focus, hovered, and press. And then if the state contains focus, then it will actually turn red. So I'm going to show you what focus is, but give me later. Then if the material state is hovered, it will be green. And if it's blue, if it's pressed, then it will be blue. So these are the different, I guess, ways for you to actually migrate from having this into this. So let me save this. Okay, now let me do the focus color. So this is like a Flutter web app. So focus is basically you want to select a certain like element or certain UI component, for example, buttons, right? So if you are lazy to like select, you press tab. So this is the select or focus color. So for the flat button is red. Then for the text button, it's also red. So this is like how this simple, I guess, if statement with the resolve with overlay color works. Then if you want to, for example, do a hover, so if you hover over the flat button, it turns green. And then same goes with the text button. If it contains the material state hovered, it's green. And then lastly, if you were to press it, it becomes blue. So the splash color becomes blue, while the new text button over here will also turn blue. So this blue is actually a shade of 100, which is very, very light. Then at the same time, if none of this state is containing the different material state that you need, then you probably have to return null, which refers to the widget's default. So the text button default. Okay, so now you might be thinking that's a lot of things that you need to do just to actually make the buttons change color when they're hovered. So is there an easier way to style the buttons? So I'm going to demo you with this outline button over here. So can you tell which is the new one and the old one? So, if you have noticed, one is in present tense and the other one is in correct past tense. So to create the outline button is pretty simple. The old one, you just pass in a simple color. But the new one now, how you're going to make it easier for you is that because there's 3 different types of button inside the material library, right? You can actually use the method style from. So this style from method is like a convenient way for you to actually just give the color to this method, and then it will actually help you compute how the interaction should look like. Because I think as like developers, we just want to push out as fast as possible, so we don't want to think so much, especially if you have side projects and design is not like your main priority, so you can just put this thing in. So there is this thing called primary, and primary is basically like the primary color of the outline button. And then at the same time, you could see familiar things that you have actually used if you were to want to have a different shape. So stadium border is like a peel type of like shape, and then the side you can put in a border side as well. So style from method, it's a convenience method that constructs an outline button from the button style given simple values. So this style from can be used in other other buttons. So text button has its own style from, and then elevated button has its own style from method as well. So the difference is that this between these two is the button style object. It's a little bit unclear for you to configure the button styling, but it gives you granular control on how any interaction should be shown. But for the so you could see that the material state property, you can see you can return a color if it's hovered or pressed. But for the style from, which I'm going to show later after this, it's actually pretty simple. It's a clearer way to configure button styling. And at the same time, I would say it gives enough control on how any interaction or, different configurations or how the button should look like. So let me demo you quickly on the different styling. So let me use the line buttons or outline buttons. And then for the outline buttons, we have the simple case of hover color, splash color, highlight color, and such. See the outline button? Yes. So the outline button, the difference is pretty simple. It's like a text button, but with just an outline. So let me zoom in for you guys. So it's just an outline. But the cool part is that for the outline button, it only makes the purple color at the border, while the outline button is, I like it a lot. It just fills up very nicely. Okay, so for the outline button, you can just do as per usual the old way, but for the new way, for the outline button, you could see that you can use the style from property. So let me go through a little bit on style from different properties that you can do. So you got like padding, you got minimum size, you got shape, you got primary, and you have like on surface. So I'm going to show you a little bit on like, for example, primary. So let me save this. Then you can see that now it actually changed the whole like overall color or the primary color. Yellow is a little bit bright. So let me put red instead. Okay. So now, okay, it's so much better. The outline button is now it actually handles for you everything. So lastly, there is this thing called on surface. So on surface is another word for saying that when the button is disabled. So on surface, let's return a color green, for example, right? And then in order for you to disable a button, you pass in a null value on your on pressed parameter over here. So let's do that. So you could see that the outline button over here is actually not is not clickable. But the cool thing is that the new buttons, right? Okay, let me show a difference as well. So for the outline button, for the on press, let me put a null as well, and you can see the difference for the buttons, right? So for the outline button over here, you could see that nothing really changed. Your cursor just doesn't change. I'm using Flutter Web, by the way. So then the new buttons, right? If you were to like hover over it, you could see that your mouse actually changes into another cursor, which I believe this is like the disable button cursor. So I guess that's the new thing that you can do, which is you can also add in like how your cursor looks like. And then there is also the theming where you can actually add in the colors when it's on surface or disabled. Right, so it's pretty cool. Now let's go back to the slide. So I would say it gives enough control on how any interaction. So if you want more granular control, you can use the button style object. So now we talk a little bit. So we have seen how we can change the color and we use the different properties of the new buttons, right? Can the text style shared through the app? Text style, sorry, it should be button style. But the answer is yes, even though if it's text style. So we're gonna be using themes. So themes are basically like a way for you to make your app look consistent and easy for users to not be like use your app. So I mean, it makes users easy to use your app if you have a consistent design. So as a developer, why should you care about theming? Right. So theming, if you were to work with designers, right, designers have this thing called design systems. So design systems is where you are able to have a particular way for a certain app should look like, right? And then the thing is that the theming will actually help you work with designers because it allows you to share your typography, primary or accent or secondary colors across your whole app. So the advantages is that you don't have to recreate a style from scratch, or and at the same time it's consistent with your designer's design system. And then you also can do changes without going through every file, right? So that was the problem initially when people wanted to change the style of a button. They can't do through the theme for some reason. So that's why theming actually helps in the new material buttons. So for example, if you want to create a simple button theme, this is how you usually do it. So I want to create a button theme that is in blue color. So this is the old way that you do it. Then if I were to make it a little bit fatter on the left and right side, you probably add some horizontal edge insets. And then the problem is that all of the buttons actually has the same color, but sometimes you want different colors. So how you do it, so it will be same for the old buttons, which is called raised, flat, and outline button. So is there a way to separate the button themes? Yes. So how you're going to do that is this. So for the old button theme, you add in a button theme data, but for the new material buttons, right, you have three separate different theme for for your text, but three separate themes according to your three separate buttons, right? So your text button theme, elevated button theme, and your outline button theme. So all of them requires the theme data accordingly. So if you want to, for example, change the text button style for all of your different apps, right, then you can actually do that. So for text button, it probably looks something like this. And then for your elevator button, you want to make it a little bit red and a little bit more like a pill. So, and then you want to change your style as well. And then your outline button, you want to make it a little bit more yellowish and a bit more boxy. So all of these actually will be according to the style that you actually pass through your theme data, which is perfect because I think most of the time we want to, add some flair to the different types of buttons. So another question is, will the old buttons be deprecated? So I think you guys probably know the answer. Yes, because I think it's easier for you to actually style the different buttons, and it will make your life so much easier because I guess if you want to have different style for the different types of buttons, it will be better. And yeah, you have like probably I will recommend you to actually migrate them. But that's about it. So do you guys have any questions? Did I take a lot of time? No. Okay, cool.
Yeah, he has thanks for that. Actually, I have you mentioned about deprecation. What about timeline for that?
Timeline for the deprecation. So if I'm not wrong, yeah. So if I'm not wrong, 1 year, like that's how long Flutter teams gives in terms of like deprecation. But I don't know exactly when it will actually be like removed. So probably a year or so. If I'm not wrong, there is a video talking about how long a deprecated thing will take. Yeah.
Okay. Thank you. And I believe it was clear. So, guys, if you have any questions, please drop it in live chat. Thanks, Harris. I think that's all for us for today. It was our last presentation. Thank you for joining us. And also, I would like again to thank all our speakers and Google Developer Space for helping to organize this meetup. So thanks, everyone. Yeah.
No questions? Great.
Yeah. Okay. Thank you. Bye.
Thank you. Bye-bye.